In this lesson, we are going to classify a sequence as arithmetic or geometric. We are going to find the common ratio for a geometric sequence, and we are going to find the nth term of a geometric sequence. We will also be able to find the sum of a series using summation notation. A geometric sequence or series is one where the ratio of any term to the previous term is constant, and the common ratio is the constant ratio, which we denote by r. This will be very similar to the arithmetic sequences that we did last lesson, except in a geometric sequence we are using the ratio instead of the common difference. In the first example, we are going to decide whether each sequence is geometric. So we have to find a pattern, and remember, in geometric sequences we are looking for a common ratio and not a difference. So this means that we have to look for something multiplied or divided that is constant between each term. Whereas in the arithmetic sequences we had to look for something that added or subtracted between each term. So we notice that from 4 to 8, or negative 8, we are just multiplying by a negative 2. From negative 8 to 16, we are also multiplying by a negative 2. And from 16 to negative 32, we are also multiplying by a negative 2. So the answer is yes, this sequence is geometric. In the next example, to get from 3 to 9, we know that we multiply by 3. To get from 9 to negative 27, we are multiplying by a negative 3. And so on and so forth. We get times positive 3 and times a negative 3. Okay, so in this example, we have a common constant, which is 3, but notice we're alternating from positive to negative, positive, negative. So this is not geometric because we need it to be exactly the same constant, positive 3 or negative 3, not both. Similarly to the arithmetic sequences we did last lesson, we also have a rule for an nth term of a geometric sequence. The nth term of a geometric sequence with the first term, a1, and a common ratio, r, is given by an equals a1 times r to the n minus 1 power. So the example says to write a rule for the nth term of the sequence 5, 2, 0.8, 0.32, and then it's going to ask us to find the term a8. So we'll begin by writing down the equation that we are given to determine the rule for the nth term, and this is a sub n equals a1 times r to the n minus 1 power. Notice that we are trying to find an, so that will just stay an. We know the first term, a1, is 5, but we are missing the r, so that's what we need to find. Remember that r is the common ratio, which is a constant ratio between each term. So an easy way to find this is to, one way, take 5, which is our first term, times the ratio and set it equal to the next term, which is 2. If we divide both sides by 5, we get that the common ratio is 2/5 or 0.4. You also could notice that the ratio is the difference or the ratio between each term, so we could have taken 2 divided by 5 originally, the second term divided by the fifth term, to determine our ratio. So there's 2 separate ways you can do that. Whichever is easiest for you will be fine with me. So now we have the common ratio, so we can continue on with our equation. So we get 5 times 0.4 to the n minus 1 power. Because we are unsure what n is, this is just writing the rule. So this would be our rule for the nth term. And now it's asking us to find a8. So for finding A8, our n, this means n is equal to 8. So if we plug that into our equation, we get 5 times 0.4 to the 8 minus 1 power. And if we plug that into our calculators, we are going to get 0.008192. So that will be our answer for finding A8. In the next example, we are asked to find a rule for the nth term when we're given one term and the common ratio. So if you remember from the previous slide, our rule is an equals a1 times the ratio to the n minus 1 power. So we notice that we have the ratio and we have what a4 equals, but we are missing the first term. So how do we find the first term? Well, we use what we know and substitute those values into our equation to determine our first term. So we know that an is equal to a4, which is equal to 3. So we get 3 is equal to a1 times our ratio 3 to the n minus 1 power, and we notice that n equals 4, so we have to the 4 minus 1 power. So we find, if we simplify, we get 3 equals a1 times 3 cubed, which is 27. 3 equals 27a1. And if we solve for a1, we divide both sides by 27, and we get that a1 equals 1/9. So now we have all the pieces of our equation. We can now substitute them in and write a rule for our nth term. So we have an equals a1, which we found was 1/9 just now, times 3, which is our ratio to the n minus 1 power. So that will be our rule for the nth term in this example. The next example is asking us to write a rule for the nth term when we are given two terms. This one is a little bit trickier, but we'll go through it slowly. So remember, our equation is an equals a1 times r to the n minus 1 power. Okay, so remember that our r value is a ratio. So we can use this to find the ratio using the two equations that were given. So we can substitute the values in from the two pieces of information that were given right here. In the first equation, we're given that a2 equals -4. So that means that -4 equals a1 times r to the 2 minus 1 power. And our other equation, we are given that a6 equals -1024, which is going to be equal to a1 times r to the 6 minus 1 power. Since we know that these are in the same sequence, we can find the ratio by finding the ratio of these two equations. So what we're going to do is actually divide the equations by each other, because we have two variables here that we are unsure what they are. So this is going to be the easiest way to figure out the pieces that we're missing. So from here, if we divide these out, we can cancel our a1s. We're left with -4 over -1024 is equal to r to the 1 power over r to the 5th power. And if we simplify that, we get that 1 over 256 is equal to 1 over r to the 4th power. We can use this equation. If we simplify and bring everything up to the numerator, we'll get r to the 4th power equals 256. Now we need to solve for r. So we know that we can do that by taking the 4th root of both sides. And just like when we take the square root, we need to account for the positive and the negative values that we get. So we are left with r is equal to plus or minus 4. Now we have two cases. We have case 1, I'll change my color, case 1, where r is equal to a positive 4, and case 2, where r is equal to a negative 4. Two cases. Okay, so if our r is equal to a positive 4, we can then use our equation again and substitute our values. So we'll use our first case for the a2 equals negative 4. So we get negative 4 equals a1. Our r value we found is 4, so we get 4 to the 2 minus 1 power. You are able to use the second equation, the a6 equals negative 1024, but I'm going to use the a2 equals negative 4 equation because it has smaller numbers. Okay, so from here, then we just simplify, simple algebra again. We get negative 4 equals a1 times 4, divide by 4 on both sides, and we get that a1 equals negative 1. So in our first case, we get our rule is an equals negative 1 times a positive 4 to the n minus 1. In our second case, we'll use the a2 equals negative 4 again, so we get negative 4 equals a1 times negative 4, which is the r value in our second case, to the 2 minus 1 power. Again, n is 2 because we're using this equation. So if we simplify, we get negative 4 equals negative 4a1, and we get that a1 equals a positive 1. So in our rule for our second case, we get that an equals 1 times a negative 4 to the n minus 1 power. Notice that if we substitute our values in, we will get the same answers. These are just two different cases for a rule for the same equation. In this example, we are given a formula to find the sum of a finite geometric series, and that is Sn equals a1, which is our first term, times 1 minus r to the n, remember r is our ratio, over 1 minus r. So using the information that we are given, the series is 1 plus 5 plus 25 plus 125, and we're asked to find the sum of the first 10 terms. So if we're finding the sum of the first 10 terms, that means we're finding S10, and that is going to be equal to a1, which is 1 in this case, times 1 minus, we need to find the ratio. How do we find the ratio? Remember, that is what we're doing in between each term to get to the next one. You can either say that r equals 5 divided by 1, which is 5, or you can notice that we're just multiplying times 5 each time to get the next term. So r equals 5. Now we can substitute that value into our equation. So we get minus 5 to the n is 10 in this case, over 1 minus 5, which is just the ratio. So we're going to get S10 is equal to 1 minus 5 to the 10th over negative 4. This is a rather large number, so we're just going to plug it right into our calculator, and we will find that S10 is equal to 2,441,406. And that's how you use the equation to find the sum. Okay, we're going to do the same type of equation now, and then it asks us to find one more step. So first it says, find the sum of the first 10 terms. Just like the example we did before, we're going to remember that we need our r value before we can continue. So we'll do that first. R is going to be equal to 2 divided by 4, or 4r is equal to 2. So we note that our r value is 1/2. We can use this information now and substitute it into our equation to find part A. So we have S10 is going to be equal to A1, which is 4, times 1 minus 1/2 to the 10th power over 1 minus 1/2. So we get, if you plug this into your calculator, we will get S10 equals approximately 9922. Okay, so for part B, change colors again, we're asked to find n such that Sn equals 31 over 4. So we're just moving backwards in this example. So we're given our Sn, which is 31 over 4. We're using the same series from the top equation, so we know that A1 equals 4. We know that our R value is 1/2, or 0.5. So we have 1 minus 0.5, and we're looking for n. So we'll leave that just as such, and divide it by 1 minus 0.5. So if we simplify, we can divide both sides by 4 to get rid of what's on the outside. So we will get here 31 over 16 is going to be equal to 1 minus 0.5 to the n over 0.5. Now we need to simplify this further. We're looking for n, so we need to try and find a way to get n all by itself. So we're going to take this side of the equation times 0.5, and this side of the equation times 0.5, which will give us 31 over 32 is equal to 1 minus 0.5 to the n. If we subtract 1 from both sides, this is simple algebra again, we get negative 1 over 32 is equal to negative 0.5 to the n. If we take each of these times a negative 1, we can simplify this into positive values. So we get 1 over 32 is equal to 1 over 2 to the n power. Notice that 1 over 32 is actually 1/2 to the 5th power. So we will determine that n is equal to 5. One other way that you could have solved this problem, I will write it in red, or use logs. That would be another way to solve this equation. Logs are a little bit trickier, but we definitely know how to do that. So if you wouldn't have been able to figure out that 1 over 32 was equal to 1/2 to the 5th power, you could have used logs to solve this problem, and you would have also determined that n equals 5. So throughout the lesson, again, we had a couple of very important terms that we need to remember: geometric sequence and common ratio. We were given a rule for the nth term of a geometric sequence, and we were given a very important equation to find the sum of a finite geometric series. So hopefully those are in your notes, and that will conclude this lesson.